and welcome to an episode of Ian's Repair. I am your host, Mr. Fix-It. In this video, I'm going to show you how to test a bipolar transistor, including both the NPNs and the PNP transistors. Now, it's very simple. You're going to need your ohm meter and the transistor and some resistors, and I can show you two different ways that you can test the transistor to see if it's any good. First, I'm going to show you how to use the ohm meter to test the resistance of the transistor. The second part of this video, I'm going to show you how to test the ammeter, or the amperes, using an ammeter to test to see if the transistor is good. So let's get started. Here is a simple test that we can do to test the transistor's functionality. To do this test, you're going to need a 9-volt battery with the connectors. You're going to need an ohm meter, a breadboard to attach two circuits together, a 10 kilo ohm potentiometer. This allows us to adjust the current flow to the base. You'll need a 1K resistor. 1/4 watt will be fine. This is to limit the current going to the base. You're going to need your probes. The negative probe connected to the emitter. The positive probe connected to this collector. This setup is for this NPN transistor. Now, the PNP transistor is similar to hook up, which I'll show you momentarily. Now, you'll also need your jumper wires if you're going to use your breadboard, so you can connect your circuit together. Now, I know it looks a little confusing on this board as to how everything is connected. So here's a diagram to help better explain how this is going to work. In this diagram, you'll see my DC power source, you'll see my variable resistor, or the potentiometer, potentiometer, whatever you want to call it. They're all known as the same thing. You'll see my 1K kilo ohm resistor, my NPN transistor, and I will show you later in this video on how to connect a PNP transistor, and it's very similar, but I'll show you what changes. Now, you also see my ohm meter. I have my red probe, which is the positive, connected to the collector. I have my negative probe, which is the black one, connected to the emitter. Now, notice that they only show the common ground. They're not using the positive. They're not connected in any way. I'm using a 9 volt because the ohm meter is a 9 volt too. Now, if something was wrong, whether I mistakenly connect something in backwards or the transistor is shorted somehow, then there's not a voltage potential difference between the power source and my ohm meter. So I don't have to worry about power going from the battery to my ohm meter and possibly damaging it. And that's one thing you want to keep in mind. Just use whatever voltage your ohm meter uses, use that same power source. Then that way it doesn't feed back through your ohm meter in the event you make a mistake or the transistor is shorted, and prevent you from damaging your ohm meter. Now, once you connect your power, here is what the current will do. You'll notice that the current goes through the kilo ohm variable resistor. Now, you'll also notice how it splits up. Part of it will go to the base, while the remaining part of it goes back to the ground. Now, this is what the variable resistor does. It creates a voltage divider. Now, as the current flows through the base, you'll notice it turns on, and it flows through the emitter back to ground. Now, for the ohm meter, once the current is turned on, now it can measure how much resistance is between the collector and the emitter. Notice how the current do not interchange each other except for in the emitter. The current from the ammeter goes back to the ammeter. The current from the battery goes back to the battery. And this is basically how this testing will work. Here I have the ohm testing for a PNP bipolar transistor. Now, as you can see, they're not that much different. The only thing that changes is the polarity. This time we're sharing the positive side of the DC power source and not instead of the negative side. Now the same rule applies, except this time the current will flow through the emitter and out of the collector. The arrow always indicates which direction the current will flow. If it's a PNP, as indicated here, then the base needs to be a negative voltage in order for the transistor to turn on. NPNs require a positive voltage or positive current, since these are current dependent. Now when you plug the power in, this is how the current will flow. And it's very similar. The only thing that's changed is the polarity. Now, let me connect my battery. Okay, now there should be current going through my transistor. So let's turn the ohmmeter on, see what's going on. Turn my little light on. Now, as you can see, we do have current going through the transistor. Well, in this case, the ohmmeter. The ohmmeter is measuring the resistance between the collector and the emitter. As you can see, it's dropped down to just below 30 ohms. This means that there's enough current going through the transistor that the resistance of the collector to the emitter has dropped to 30 ohms. This is what they're supposed to do. Now, if you were to remove the power to the base, you should get this. You should get no resistance whatsoever, or the resistance is so high that the meter cannot measure it. In this case, mine can only go up to 40 mega ohms, and it cannot read the resistance beyond that. Now, if I was to plug my positive back in, the transistor should be conducting. Now, watch what happens. These things are called linear transistors because not only can they be turned on and turned off, but they can actually control the amount of current flowing through them. Now, for the NPNs, the current will flow from the collector through the emitter. PNPs are the other way around. The current will flow from the emitter to the collector. Now, watch what happens when I decrease the current to the base. Notice how the resistance between the collector and the emitter goes up. And this is what they'll do. They just keep going higher, and they go higher, all the way to the point the transistor just shuts off. Now if you decrease and see what happens, the more current you apply to the base, the lower the resistance becomes, and the more current that can flow through the transistor. And if you decrease the current, the higher the resistance. This is why they're called linear transistors. Now, you can use a trimmer potentiometer, which will give you more precise control as to how much current applied to the transistor. But you'll see me using these transistors later on in other videos. Well, now we have this ideal set down. Let me show you another test that you can perform. Here's another test that you can perform on your transistor. Now this will work on whether it's a PNP or NPN transistor. This one I have connected currently is an NPN transistor, meaning that the transistor will come on when I apply a positive current to it. Now, as you can see, I've got my meters turned on. I've got my battery connected. What we're going to do is measure the collector current with this meter. We're going to measure the base current with this meter. And finally, we're going to measure the current through the emitter with this meter. Now, you don't have to go out and get all multiple meters if you had to. You can do this with one meter. But for this video, I'm going to demonstrate all the ammeter readings at one time to show you what takes place. And I'm going to show you how sensitive these transistors can be. Now, with the battery connected, I have power to the board. Now, as you can see, the transistor is not on, so we're not pulling any kind of current whatsoever. Now, let's increase the current to the base. Notice how little the current through the base compared to the collector and the emitter. You'll see a significant difference between the two. Now, I'm going to stop this, or try to stop this, at 1 milliamp for the base. Yeah, that's pretty close. Now, I want you to take a good look as to what's going on between the collector and the emitter. Have you noticed what's happening here? Now, this is a good way to know if the transistor is actually working as it should. The collector current is pulling 40 milliamps. The base is pulling 1 milliamp. The emitter has 41 milliamps passing through it. Now, this is the best way to know if the transistor is working. The collector current plus the base current should equal very close to the emitter current. Now, as you can see, this is 40. This is 1, so 40 plus 1 is 41. So the emitter current should be around 41 milliohms. Now, as you can see here, it's just 1/10 of a milliamp off, which is good. They're fairly close. And of course, I'm running long wires because I didn't have the adapters for my new meters. But as you can see, they are very, very close. Now, if I could turn it up just a little more, you can see how everything will change. you can continue. And the more current you give to the base, the more current that's going to flow through it. Now, everything that you do, you'll notice that the current flowing through the collector is at 40 milliamps. You'll also notice that the base current is at 2 milliamps. So when you add the 40 plus the milliamps for the base, you should get about the same thing as the emitter. Because what's happening is the collector current goes through the transistor, the current from the base goes through the transistor too, and when they meet up, the total between the collector and the base should equal to the emitter current. And this is a good way to know if the transistor is working. Now, I've got the transistor on a very low current because I don't want it to heat up. I don't have it on a heat sink. But this is a demonstration to show how these transistors work. Now, you can see how sensitive this transistor is. Now, let me go all the way down. To where it starts to pull current. Now, we're back to 0. Now, take a look at this. I'm only using 3/100th of a milliamp, which is right around 30 microamps. Or, yeah, 30 microamps. Such little amount of current can control such a larger amount of current. With just 3/100ths of 1 milliamp, I can draw and have the transistor handle up to 8 milliamps. So you can see the huge difference between the two. Now, as you increase, you'll notice that the amperes increases between the collector and the emitter. Now, keep in mind, the collector current plus the base current should equal very close to the emitter current. This is the way you can tell if the transistor is functioning. And by adjusting it, you'll know if the transistor responds as it should. Now, all I'm using is a 10 kilo ohm potentiometer, which is this one right here, and I'm using a 1 kilo ohm resistor to limit the current to the base. Now, the resistor over here is a 220. I'm using this for the load to simulate current flowing through the transistor. Now, as you can see, this is all that takes to test a transistor. Here is the illustration of how I had the board set up. You don't have to have 3 meters, you can just use one. I'm showing you now as to the 3 test points to connect your ammeter to get am readings or ampere readings. This picture here, or this illustration, is for an NPN. Now for this, the test point 1, which is the collector, test point 2, which is the base, those 2 ampere readings must equal or be very close to the emitter current that you're getting from test point 3. The resistive load can be anywhere between 100 to 300 ohms. You don't want to pull very much current, just enough to trigger the transistor to come on. Without the heat sink, it can heat up, and you don't want it to do that. Here we have the same kind of test, but for an PNP transistor. And the same thing goes for it. The collector and the base current should add up to equal the emitter current. And be sure that you watch your polarities for these, because they are quite different from one another. The NPNs are the opposite of the PNPs, and vice versa. So keep an eye on your polarities. Well, this concludes this episode of ES Repair. You learned how to test your transistor using an ohm meter and some resistors and a 9-volt battery. You've also learned how to test the amperes going through the transistor. And these are two good tests that you can use to ensure that the transistor is good. Now, I do have other videos coming up to test thyristors and to test field effect transistors and other transistors that comes along. So stay tuned. Be sure to subscribe if you haven't already. And be sure to vote on these videos that we upload to let others know if you like the video or not. And of course, your comments are welcome. Well, I'm your host, Mr. Fixit. Thank you for watching.